Good morning to everyone. I'm Dr. Sumiyamas. The topic of my today's presentation is sum of product and product of sum from Unit 1 Boolean Algebra and Logic Gates of Digital Logic Circuits and Design. On completion, the students will be able to understand the difference between sum of product and product of sum forms and also describe the canonical and non-canonical sum of product forms. Sum of products form. The SOP or sum of products form is a form of expressing a logical or Boolean expression. Here, different product terms of input variables are logically ORed together. Therefore, in the case of sum of product form, we first logically AND the input variables and these product terms formed are summed together with the help of logical OR operation. For example, function of a, b, c, we are having three inputs a, b and c, and a, b, c plus a bar b, c plus a, b, c bar. Sum of products form. The above given expression is a logical expression in three variables. Here a, b, c, a bar, b, c and a, b, c bar are the three product terms which are summed together to get the entire expression in the sum of product form. Non-canonical sum of product form. In this form, each product term may or may not contain all the input variables in all minterms. That is, in the given example, f of a, b, c is given as a plus b bar c plus ac. So here a, b, c are not present in all the input, all minterms summed together. Canonical sum of products form. In the canonical sum of product form, each product term contains all the input variables that are present in the function, where variables in each product term can be in true form or in its complement form. So in this example, f of a, b can be given as a bar b plus a b bar. So here a and b are the only two possible inputs and they are present in both the minterms, either in a direct form or in a complemented form. Product of sum form. The product of sum or POS form is another form used to represent a logical expression. In the POS form, different sum terms of input variables are logically ANDed together. Hence, if we want to express a logical expression in POS form, we first logically OR all the input variables and then these sum terms are ANDed together using an AND operation. So for the given example, function of a, b, c is given as a plus b plus c into a bar plus b plus c into a plus b plus c bar. So we have three max terms being ANDed together. Here f is the logical expression in the above with three input variables a, b and c. So it can be seen that there are three sum terms which are ANDed together to obtain the product of sum form of the expression. And here we have two types of product of sum form: canonical product of sum form and minimal product of sum form. In canonical product of sum form, we have all the variables present either in the normal form or complemented form in each of the max term. In contrast, in minimal product of sum form, we do not have all the variables in the complemented or uncomplemented form in each of the max term. Applications of sum of product. Digital circuit design. It is the sum of product form is utilized very often in the implementation of combinational circuits like multiplexers, encoders, decoders, etc. Logic minimization. Most of the logic minimization approaches ranging from K-mapping to Quine-Klasky uses the standard sum of product for better construction of digital circuits. Programmable logic arrays. In programmable logic arrays, which is a configurable device, the logic is defined with the help of sum of product expressions. In designing finite state machine. While designing finite state machine, the transition logic between the different states is expressed in the form of sum of product form. So this is a example for product of sum form where the function is in terms of inputs x, y, z. The function output f is given as x plus y plus z into x plus y plus z bar into x plus y bar plus z bar. It is in a canonical product of sum form. By applying different Boolean algebra, we are simplifying it and minimizing it into a form where the output f is equal to x plus y into x plus z bar. So here we are having two max terms, but we are not having all the variables in these max terms. So this is a minimal product of sum form. So we can obtain both product of sum as a canonical form as well as a minimal product of sum form. Quiz questions on sum of product and product of sum. What do you mean by sum of products form? Define product of sum form. Describe the canonical and non-canonical sum of product forms. With an example, describe minimal product of sum form. Thank you.